We'll talk about girder repair and bridge jacking. How many in here have had steel girder repair projects? Yeah. All right. I was expecting that hand to go up. So these don't come around very often. We've got a few going on in the state right now, but in my career, my 24 years with the state, I really only had one that I was responsible for with the resident office. So they don't come around often. We want to present this info so you see it. In case you get one, you'll kind of have an idea of what you need to do, who you need to contact, and what the procedures are. So we'll go ahead and get into it. All right, so the first thing is inspector. What you're going to do, you're going to determine the areas you need to repair. The plans are going to spell these out for you for the most part, but you're going to go out in the field with a contractor, get up in the man lift, eyeball these, and see what they look like. But that's just your initial survey. All right, so these estimates are on the plan, but they could change. You know, in the field, sometimes you'll see more. If you spot some additional ones when you go up in the man lift, you want to clean these areas up also. You're going to get out there, they're going to sandblast these, hopefully 3 inches beyond the areas of repair is what you want. That's what the welding specs recommend. So you want to clean these up really good. You're not going to measure it until you get to that point. Why? Because of rust. All right. Pack rust, 1/8 of an inch of section loss usually leads to 3/4 of an inch of rust. So your rust is going to build up 10 times the rate of whatever your base metal is. So you got to get rid of all that rust before you can start doing any measuring for section loss. Once you do this initial verification, you're eyeballing it with a contractor, figuring out where these areas of repair are at. You're going to get out there and clean them, have them clean and blast. And it may be the same contractor, that he may have a separate contractor come in to do this. But in order to determine how large that area of repair is, you need to get it cleaned and primed. All right, so here's, hopefully you won't see one quite this bad, but these are some possibilities you could run across when you get out in the field looking at them. And it, like I said, it can expand, the rust can 10 times to what the base metal is. And you can lose, you know, up to 1/16 of an inch of actual section loss. That pack rust you see could be as much as a 1/2 inch thick. So the areas like this, you want to get in there and get them cleaned out really good. You see this beam goes into a concrete diaphragm. You're going to see some more pictures of that here in a minute. Here's another example here. It's hard to tell exactly how bad this beam is. You know, you see it's well corroded. But the extent of what repair it's going to need, you won't know till you get in there and clean it off. Wanted to point out the bearings too. You know, they look in pretty rough shape, but until you get out there and clean it, you're not going to know. If you get a bridge like this, where these bearings look pretty bad, maybe it calls for a beam end repair, and that's all you got on the contract. Discuss with your resident. If you get up there and you see these bearings like this and you determine in the end that hey, we think they need repairing, check with bridge maintenance, check with your resident. While you've got this bridge jacked, it's a good idea to try to repair these at that time. The expense lies in the bridge jacking and that setup. If you can get in there and, you know, repair the bearing pads at that time, it's a good idea to try to do that. But there's, you know, a lot more factors go into whether or not they're in the contract. So make some phone calls on that. All right, so this is a pretty obvious repair here in a stiffener. You know, it's 100% section loss, of course, where the hole is, but you can, it's harder to see down below it, but there's a lot of corrosion there. And once you start blasting this out, you know, this hole could widen, you could get very thin in here. So once you get that cleaned up, you know, that area of repair could be enlarged for sure. This here is a beam that buckled. You see the obvious area where it's going to need to be replaced and have a beam end repair. I wanted to put this one in there too because this shows you where it's been cleaned and primed already. This one's ready to be measured, so you can measure up this repair. And Cameron presented earlier, and he actually said that there was about 16 inches of asphalt on this bridge that helped cause this beam to fail. So, you know, in your other contracts, loading these beams and paving over bridges. Sometimes that's why we don't want that. It puts that extra weight on the bridge, puts the extra stress on the bridges and the girders. All right. Some of you in this class were on this bridge project here. This is a bridge we had down in Chapel Hill. I put this in here to show these beam ends going into these diaphragms. A lot of these older bridges you had back in the 50s and 60s had these diaphragms in them where the steel girders actually are encapsulated by that diaphragm. So a lot of these repairs, you can see the corrosion here on these couple of beams here, but it also goes into that diaphragm. And on your plans, it's going to call for you to chip out these diaphragms around these steel or beam ends so you can fully repair that beam. Because if you just repair the part that's showing, you know, there's still that deteriorated section in there you're not getting to. So just want to show you what those are. Here's a contract we have. This is up in Buncombe County. It's a steel repair project, but you see on the diagram here, it's got a layout of where all the repairs are that they've scoped in the contract. Typically, your designer is going to go in there. Hopefully, they've gone out in the field, but they're also going to take the biannual bridge inspections and note the issues where bridge maintenance has noted that there are issues, and then they're going to verify that and put these in the plans. But when you go out there, you know, you're going to verify it yourself with the contractor. You see the legend over here on the right. I mean, it's kind of hard to see, but it's going to call for what the repair is, whether it's a stiffener repair, flange repair, web repair. You're going to have it listed there. You can see down in this chart here, they've got the measurements. And in the end, these are all estimates. So those of you who are doing electronic as-built now, anybody still doing traditional as-built, pencil? All right, but whatever software you're using, you know, you're going to have a lot of space on most of these pages. You want to make that chart and just make what you actually come up with on your measurements, what you're going to pay for. You're going to have that in your pay records also, but it needs to be reflected on the as-builts because bridge management is going to go back. They're going to record this. Hopefully, in some cases, it'll upgrade the rating of the bridge as well for the repairs we make. But they need to note the actual repair, not just what was in the plans. All right. Here's a typical section you'll see. This is kind of out in the span. It's at the bottom of the beam next to the flange. So this is a generic repair. You're going to follow the table. You kind of see the cutout that they're, you know, got around the beam or around the area repair, sorry. But you'll need to take measurements once you get out there and get it cleaned and primed, and it's ready to go as far as repair. All right, here's another one. This one was actually provided by Bridge Maintenance. Shows a beam end repair. And you can see how they've got it cut out. If the contractor decides to square up an area repair, this one here is an irregular area, you see. It goes up into the diaphragm. But if the contractor may elect to square this area up, and I'll show you a diagram in just a second. This actually happened in this bridge in Chapel Hill. I got a call from assistant resident on this one. These old beams like this, some of them do not have Nelson studs on them. So when you go to jack these bridges, that beam is going to want to drop out of that deck. And I think it kind of startled everybody when this happened, including myself when I started making some phone calls. But Cameron had verified that going back in the 50s and 60s, a lot of these short span bridges, they didn't put Nelson studs on. So when you get in there and make repairs and you start to jack, you know, that beam sometimes is going to want to come out of that deck. And it actually helps in some cases when you're making these beam end repairs because it becomes more visible. You can get to it a little easier. But if something like that happens, and lots of times on these rehab jobs, you're dealing with, you know, different specs we had back then. So a lot of different things, different size rebar. You'll run across all kinds of things on these old bridges that, you know, it's not standard construction nowadays.
Copper water stops in the
Yep. But Cameron mentioned this earlier. Try to get a hold of your old plans. And some of these bridges, you know, that date back, you know, most of the bridges in the 30s and 40s, most of them were taken care of. We're replacing those by now. But, you know, we still got a lot of 50s and 60s bridges out there. And those plans, when they've transferred them from paper to microfiche, you know, sometimes those lines are blurry in what you can see. But if you can't pick up, you know, the girder detail, stuff you need, info to verify, make a phone call to somebody. Structures usually has a copy of these somewhere that they can get a hold of and check on it for you. So before you know, don't do anything, make some phone calls and see if the information's out there on these on the as-builts for these old bridges. All right, and here's that same repair. The dimensions are color-coded here as to what, you know, you see it in the chart here. Some of them only have the 2 dimensions if they're small, but these larger repairs that extend on down the girder, you know, they're going to measure them 4 dimensions is what they're going to provide for you. You know, basically the height of this one, and then they break it up into 2 basically, the height and length of this dimension. But you're going to have a chart. You know, you need to make your own chart with either Bluebeam or Adobe Acrobat, whichever software you use, and put back in here to show the actual measurements that you actually do the repair with in the end. All right, so sometimes the welder is going to come out and he's going to say, can I cut this out this way? This is easier for them in some aspects. Is this allowed? In most cases, yes, it'll be allowed. All right, but 2 things you need to know. First thing you need to do is verify with structures it's okay to do this. Okay, he's going to cut out this large area. If he cuts this out, you know, will that beam sustain itself once he cuts that larger area out? So you need to verify that with structures first and foremost. Second thing, this area in here above the original marked area repair, do we pay for this? No, we do not. This is kind of a convenience thing for the welder. He's taking a bigger piece of steel. It's easier for him to cut it this way. He's basically only having to cut the 1 radius on it to match it to the end of the beam. So it's easier for him, but he has to use more material, but that's still, it's his responsibility to pay for that. We don't pay for the additional steel here, you know, because it's not needed. He can cut this out, you know, along the original lines if he wants to, but we do not pay for that extra steel there. All right, so let's look at some tools that we're going to use to determine our section loss. This is an old piece of steel. This is Cameron's plunge. Hold on, I want to make sure I get it right. Plunge micrometer. All right, you can pick these up at Harbor Freight for about 20 bucks or so. But basically what it's going to do, you're going to level it out and zero it out. It's got buttons on here. All right, so you're going to hold it. He made this straight edge for it, so you're going to run it along the beam. And when you get to these spots, this piece comes back through and it'll measure how much section loss you got. The limitations on this though, it only does 1 side of the beam. So if you're up in a man lift and you're trying to go side to side on 1 side of the beam to the other, you know, not only maneuverability getting to the other side, but how are you going to know that you're on the same spot you were on the other side? You know, you can make lots of marks on it, and that's fine, but it takes a lot of effort to do that. So another tool that you got, you're going to have calipers. And this one here is pretty basic, but you're going to, it unscrews, and you can make it whatever the size of the flange or the end of the beam. But access is the issue with these. You know, they're only good for where you can reach with. You can't measure the middle of the web, you know, in the middle of a girder. Usually the edges is all these are good for. But this one actually, you know, you use stick tape to measure whatever you pinch here on this one. The ones on the screen you can see have a gauge on them. So it's going to tell you instantly, you know, what that measurement is. But the best tool is this D meter. M&T has these. Mike Pulley was at our last class. He's a state welding engineer. but he said these things cost somewhere between $8,000 to $10,000. So some of your contractors may have them, but most probably won't invest it to have one of these on site. But you see the inspector, he's got it set up. But early on in your project, once you get your first initial repairs cleaned up and ready to go, I would advise calling M&T, call Mike. He works out of Wilson, but he's got 3 or 4 guys that go across the state and help measure, help with welding, and help determine section loss. They'll bring this machine out to your project and help you measure it. And it's a good time to take these other tools as well and compare them with the D meter, see if you're getting close readings to what it is. Because this thing's spot on. It can stand on one side, you set it up, it shoots one side of the beam, it'll shoot all the way through it and tell you exactly what that section loss is. But it's a really good tool. But again, get M&T involved early. All right, so your rules of thumb for section loss. If it's in the web, 25% or more, you're going to repair it. Stiffeners, 50% over 1 foot vertical area, 75% over a 4-inch vertical area. So these are the requirements that you're going to follow unless there are different requirements in your contract. You'll have to check your plans and your special provisions, see if they've got different rules of thumb in it. But if not, these are the ones you're going to follow. But any time you have a hole in it and you got 100% section loss, you're going to repair it. So that's the easiest one to remember. But the others vary, just depends on if it's a flange, stiffener, or the web. But if you got questions about it and you can't find it, ask your engineer if you're in doubt. All right, so fit up issues. What are some common causes of them? Beam end repairs and stiffener repairs. Workmanship's the number one. You make sure proper cutting, check that welder out. They need to determine that they're using a mechanical guide, not only to cut out the beam, make the initial beam cut, but when they go get that replacement steel, they need to have that same guide so it fits back up correctly. If they're not using a mechanical guide, I don't care how good a welder they are, there's some that can freehand it and get it close, but eventually they'll have fit up issues if you don't make them use that mechanical guide. The materials can warp if they get them too hot. Not only the beam, but the piece they're putting back in it. If they get it too hot, it'll warp. So then it's not going to fit up right. One's not going to match up with the other. So make sure they're not getting it too hot when they're cutting it initially or going to put the fit up piece back. And rust removal. Mike sent me this at the class we were at last time. 3 inches beyond the area of repair. So you want to blast that beyond the area that may be marked on the plans and get that good and clean, get all that corrosion off of it, because when you go to try to weld back, if you still got that corrosion there, you will not get a good weld. It will not hold up well. So remember those 3 things. All right, so sometimes we're not going to do welded repairs, right? You may do one of these. This is a plate repair. I haven't done one of these in the field. We've got one now on Green River Bridge on I-26 that we're planning to do. But basically, you see the areas of repair, they're marked, and the type of plate repair you're going to put back in its place. Basically what it is, those of you who've been on new girder projects, new steel girder projects, it's almost like doing a splice. You're going to have 2 plates of steel. You're going to put that in place instead of cutting out the bad area and putting back in a new piece of steel. So you're going to have these plates and you're going to bolt them together. A tension connection just like you would on a new girder. All right, I won't go through all these details. I just put this as a second sheet. Usually all this is going to be on the same sheet. I just put it on 2 different slides here. But you're going to caulk it 100%. The picture you're going to see, it looks like it's partially caulked on it. But you're going to caulk it to keep that water from getting in there. Also, the inside part of that plate, you're going to prime it before you put it together. And that's in case any water ever gets in there, it's already primed. Depending on your contract, you may be coming back to paint over this. If not, they're probably going to specify some kind of galvanization both for the bolts and the plates. But that's something you'll have to figure out. If you're adding it to your contract, that's something you need to talk to your resident, maybe your bridge program manager. Are they coming back to paint it afterwards? If they are, then you may not need to have all the galvanization for these plates, because they'll come back and coat it when they paint it. There's just something to figure out. All right, flange repairs. This one here pointed out, I pulled this one from a diary for a project on I-26, but you can see the excessive slag that's around these edges here. I said a while ago, follow your welder around. Check his credentials when they come out to the job. Make sure you're watching him like a hawk as they get started doing these repairs. These guys need to be certified, but sometimes, they're better at some welds than they are with others. They may not be really good at structure repairs. They may be good at, welding piles and stuff, but when it comes to these kind of repairs, maybe not. Issue we got into here, the welder was actually doing these welds. He's leaving a little bit too much slag, so he's having to have somebody come behind him and grind. Well, ideally, he'll be doing these grinds as well. But instead, he had somebody else come behind him and do it that was not certified. So that's not allowed. It has to be a certified welder doing the grinds. You can have a different certified welder to do it other than the one that made the weld, but he has to be certified. And in case what happened, it's not this particular beam here, but the person that was grinding actually ground through the web where he had the weld against the web. So we had some damage to the beams, from somebody that wasn't experienced in doing this kind of work. But you want to make sure that slag, if they leave it high like this, that they get it ground down, and that they're making proper welds. How many have been through the M&T class with welding? I know Cameron asked this question earlier. Before you have a steel repair job, or if you got one as residents, inspectors, check with M&T and see if they've got a class coming up. It'll be a good time. If you've been through it and it's been a while, it'd be a good time to refresh it. If you've never been through it, I recommend going to it. It's not designed to make you an expert welder, but what it will do, it'll teach you what are good welds, what are bad welds, and good practices and bad practices in welding. Because you want to know that before you go out there, so that welder, if he gets in trouble and he's not doing what he's supposed to be doing, you can recognize what that is. All right. The web failure we had earlier, this picture here, this is what happened when they went back to try to fit it up. Not sure exactly what happened, but things didn't fit up right. And it wasn't caused by heat, but you can have fit up issues sometimes when you have the cutout. But just put that picture in there to kind of show you what can happen on a fit up issue. All right, sometimes you'll run into these little defects that are in the beam. They may or may not be caused by the contractor. They could have been there originally. But if you see these, in this case, the painter just went right over it like they weren't there. But you need to have the welder grind these out, these irregularities. The spur is probably not going to hurt anything there. Yeah, but I would if you see it. But this indention here in the girder, these can cause cracks later on if they're not fixed and ground down. But you need to make sure that they're ground flush. When you see them, we definitely don't want to paint over them and just ignore them. So if you see these while they're out there, have the contractor take care of those and not leave them in place. All right, here's all the welding procedures, and a lot of these Mike Pulley gave me last week. Just go over a couple of them. But the replacement sections that they bring out there should be as good a grade of steel or better than what's already in place. And they should have plenty of paperwork provided you this or where it came from, so you can check all their material certs on it. But they got to be certified. They've got to, carry that car with them. You need to verify it with a picture ID. It can't just be their little card that they bring out and show you, because you don't know if it's that guy or not. So you need to verify it with his driver's license or some other form of picture ID. They can submit their own welding procedures. Sometimes they'll differ a little but maybe what we want them to do or what we require. But But if they're reviewed and structures okays it, then you can proceed that way. But otherwise, you know, they're to follow our procedures and follow the welding code. And that welding code, you know, it's updated through 2020 is what Mike gave me, and it's in here. It's AWS D1.5, and it's 2020 was the last update they made to that code. All right, in summary for the steel girder repairs, make sure you determine those area repairs. Make sure you go out in the field and verify it. They're going to clean and blast it, and then that's when you measure and you determine it. Make sure you keep up with it in the as-builts. If you got any questions about anything, first line of contact is going to be Marcus. For those of you in Division 7, if you're in a different division, contact your area construction engineer there. I'll be glad to help you out on these as well. Materials and Test is an excellent resource for this stuff. They know more about the steel and the welding than we will. Mike Pulley's your guy, and his contact number's here. There's some other folks in the area that he'll send out. But do that early in your contract. Don't wait till it becomes a big problem. I would have them come out and check the areas for section loss, and as well as check out your welder once he gets started, see if he's welding correctly. They've got a machine that'll check the welds as well, make sure they're being put back in right. So do that early as you get started. Don't wait till the end or till you have a big problem, because you may find out, you know, that you do have a problem at the end, and you know you've already gone that deep in the contract. Anybody have any questions on steel girder repair? All right, we'll move on to concrete girder repair. I've only been a part of one contract where we've had concrete girder repairs. Anybody had somewhere we've had to repair concrete girders? All right, so a few. But fortunately, they don't come around real often. Concrete girders are really reliable. They're mostly not susceptible as much to the salts that we see as far as from the roadway that we put down. Not as bad as steel is. Water and salt, of course, corrodes steel really bad. Concrete provides that protection just with it in its nature to the steel and the strands that are within that concrete girder. These are typical sections of web repair and some bottom beam repairs that I cut straight out of the plans. And this is the layout. This is a bridge we actually had up in Rockingham County. But much like you saw with a steel girder, it shows the actual end beam repairs, where they're at, located on which beam, which span. I believe this bridge was 9 or 10 spans, something like that. So you had a lot of spans on it. The repairs on the girders, you know, there weren't too many to the girders themselves. They're mostly cap repairs. Darren will go over a lot of the substructure repair here in a little while. But we did have some concrete beam repairs in this contract. But it lays them out just like it does with the steel girder repairs. If you get there and find there are more girder repairs that you need, note them in there and contact somebody before you jump in and start making those repairs. They may not have been noted by bridge maintenance possibly, but we need to try to repair them if we're already out there doing other repairs. All right, so follow the plan notes. These are going to be in all your repair procedures. They'll describe the proper repair methods. If you get any questions arise that are different from the field conditions, you know, once you get out there and analyze it, contact your area construction engineer. Lots of times these plans, when you go back in, the strands, the steel that's exposed in these, you're going to have some kind of corrosive inhibitor you're going to spray back on it before you put back the repair material. So just make sure you follow the plan notes. They'll be different for every contract. Some of them will be generic, but you know, lots of times they'll have their own specific repairs for your project. This is a bridge down at Wrightsville Beach. The unique thing with this bridge is it's right over kind of the inlet that separates the island from the mainland, and it's a low bridge. It's not the big high-rise bridges you see lots of times going into the beaches. So what happens here is the jet skis that come around this bridge, they're shooting salt water up on our beams here. So you see the corrosion that it's doing to these beams. Not only is it in a corrosive environment with the salt water being that close to it, but you know, the salt water that's being launched up to it as these jet skis go under this bridge, because it's about 8 to 10 foot off the water depending on the tide, but it's coating these beams with salt water. And you can see the strands that are exposed, the steel that's exposed in the picture here. One thing I want to point out, if you see strands that have been detention, or in the next photo you'll see one that's actually about to come apart, don't just cover this back up. Tim Sherrill was at our last training, and I've talked to Earwood about this because this is in his region. There were repairs made to this bridge 2010 to 2012, and a lot of the repairs they made, they just covered back up the steel and didn't make the repairs to it. So a lot of the strength of these girders is in these strands where they're pulled apart. Those of you been to a precast plant, you know, they tension them things really tight and pour the concrete over it, but that's where it gets its strength, that and the reinforcing steel. So if you just, you know, when these are damaged, when you get in there, we need to repair them. And if that's the case, you know, if they weren't anticipating, we have repair procedures for repairing these strands and the rebar once you get in there. So just don't let the contractor just, you know, patch it back up. We want to repair that while we're in there. Here's an example where they've got it cut out as well. Good concrete prep again here. But you can see this one strand, you know, it's frayed. It looks like it's almost in two right here. So this is one we would probably want to make repairs to before we cover it back up. And again, they're going to probably put some kind of corrosive inhibitor on it before they patch it up. Also want to make note, you see they've got it anchored into the girder. We typically do not allow that. This contractor in particular, to anchor his work platform, you know, so they can walk around below, they actually asked to anchor into the girder rather than say the deck or use something other method that they would more typically use. But structure's okayed it for this, but if you're on a job and they want to anchor into the girder, just make sure somebody reviews it before you allow them to do that. All right, this is something you're probably more likely to see, those of you that are on new construction. This is the girder that came in, you know, it's damaged. Looks like they've already prepped it in this case. But want to stress too, and I didn't go over this as much with the other girders, the plan notes will generally tell you to start, you're going to saw cut out your area for the girders. They're more delicate than substructure when you're out there jackhammering. So you want to make that saw cut first and then start chipping out with the hammer and not just going, if you start chipping out first, like Cameron said this morning, you could broaden that area of repair, and we don't want to do that. But you got to be real careful too, because these strands, they're located so far in, and it's going to vary by girder. But you're going to start out with a 1/2 inch cut, try to get out your damaged concrete that way, and then if you need to go further, but you need to verify where these strands are, how deep they are into the beam, because you don't want to cut these strands. They're difficult to repair, and like Cameron said, if they are damaged, you're never going to get it back to the way it was, you know, when it left the plant. So just be careful when you're repairing these, but just want to point this out. What I like to tell people too, check with your precast plant on these repair materials. Usually I'm going to try to use what they use at the plant because that's already been vetted mainly by our materials and test folks. And if the contractor elects to use the same material, you know, that's typically what we want them to do. But I like to see it either has a bonding agent with the grout they put back, or there's some sort of epoxy mixture with that grout. Because if they just put plain grout back in this, it's probably going to fail eventually. There's nothing there to adhere to that surface. So just check that, run that through Marcus, and if, you know, if he needs to check with me, you can as well. All right, so here's some examples of some good repairs. This is the Wrightsville Beach on the left. The other is a bridge up in towards Asheville that they made repairs on. But you can see they've got it formed back up nicely, and it looks pretty good. All right, Any repairs on concrete girders? Any questions? All right, we'll jump into bridge jacking. All right, so there's two different types of bridge jacking, type 1, type 2, and that's what the special provisions call for now. Those of you who've been around for a while, bridge jacking was a lump sum item. Whether you had one bridge or 10, they had one price that they submitted for. That caused some complications not only for us, but for the contractor as well, because unless he was certain of how many setups he was going to have all those bridges, he didn't know how much money to put into it. So now we've simplified it for him a little bit as far as the pay. He basically gets paid per setup. So, whether it's type 1, if he's doing individual girder, or type 2, whether he's jacking the whole span, you're going to pay him according to those two line items. And it's easier for him. He knows how much, effort, materials he's got into it to jack, whether it's the whole span or one girder. Where it comes in for you is, depending on what work he's doing. Is he repairing the end of a beam? Is he going to repair the cap below the beam? Is he putting new bearings in it? Typically, most of this work, he should only have to jack one time at that location. But where you need to determine if he has to do multiple jacks on the same beam, is it necessary? So that's where you determine, does he get paid once? Does he get paid twice? That's something you'll have to work out with him. But it's set up now, it's a per each setup rather than a lump sum. So it makes it a little easier for him to bid and for us to keep up with. So here's a typical jacking that you might see in a set of plans. This doesn't apply to every setup. If it can't be done like this, they're going to provide a jacking plan ahead of whichever bridge they're going to work. It has to be approved. Typically that's going to run through structure design. If it's just a beam or two and it's simple, it's something that Marcus or I may review. But probably 90% of the jacking plans are going to go to structures for review. They're going to jack typically 1/8 of an inch. If they have to go higher than that, they have to raise the adjacent beams as well. Now all you want to do is jack the beam just enough to clear that bearing. So when you go to jack, what does that do to the joint? Because your joint's even. If you're jacking a span or at that cap and you start to raise one side of the bridge, what does that do up top? Makes it uneven, so it can make a bump, right? So you got to keep that in mind if you got live traffic on it. Determine if there's anything you need to do up top. Depending on how much you're raising one side of the bridge, you may need to raise the other side to make it even. You also don't want to raise it too much for the joint, because what's it going to do to that seal if you start raising one side and not the other? You could separate it or damage it potentially. So just things to keep in mind. Whatever's in the plans, it doesn't mean it's going to work for every instance. Like I said, they got to have their own plan for each detail. This is a detail from down east. Sometimes you'll see unique jacking details in the plans. I'll point this one out just to say, this is an alternative method. You can see they actually dowed into the column here, and it's sitting on a platform almost like an overhang where they're going to jack the girder. And just depending on the bridge and the makeup, we talked about some of these older bridges before and how they're constructed originally. There may have to be some unique jacking solutions you have for these. But again, the contractor is going to submit it. Sometimes they'll put in a detail like this just to give them an idea of what could be approved. But it's up to him to determine his own method. All right, and again, here's a detail of that. I also want to point out on that plan note, before you go out and jack at each span, you'll need to go up in the lift with the contractor and see if you see any damage to these bridges. Sometimes jacking and the forces they put on these bridges and diaphragms can cause cracking, chipping, spalling. So we need to determine if there's any damage out there before he gets out there. If you find any, let bridge maintenance know, make them aware of it, see if they are aware of it, and document it. And document the condition of it before you start jacking. Because if he goes out there and he uses something, does improper practices, then that's going to be up to him to fix. If he does everything like he's supposed to, and you know we've got issues with the bridge already, then we're probably just going to pay him to fix it at that point. But we just want to make sure that he's not causing any damage to the structure when they start jacking. All right, this is a typical jacking setup you're going to see. This is looking down the span at the adjacent cap. But they'll typically have hydraulic jacks out there. You know, I've seen as many as 4, just depends on the weight of the beams or the height of the beams. You know, but this is your typical setup. They'll have some wood blocks below, generally just to offset the force of that jack and spread that out, so hopefully it doesn't do any damage to your concrete. What you got to be careful is these plates, you know, at the top and on the bottom. You don't want to put a point load on those because they will chip the concrete. So they've got these set up where they got the load spread out pretty good, and they got some cushion here basically with using these wood blocks to help absorb some of that. So this is the typical setup, you know, I've seen in the past when we jack. So this is another picture from the side. So it's something standard, pretty standard what you'll see here. This is something I have not seen. Inspector from Asheville area sent me this one. Sometimes, you know, depending on what you're doing below, you won't have access to get underneath it and jack the beams from below. So you'll have top-down jacking sometimes where you actually set up on the deck. They'll create something with beams set up, and you can see they've got like threaded rods, and they'll actually drill through the deck and pull it up that way so they can get it off the bearing. So you may see a plan like this. It just depends on the bridge you're working on. But like I said, these are pretty rare. And talking to Cameron, he's seen some of these along the way, but I've never seen one. But I just want to point it out that, you know, it's something that could be in your plans depending on the type of bridge you got and the clearance you've got underneath if you're able to get the hydraulic jacks underneath it. All right. So here's one where they've actually cut out. We talked about that earlier. They can make this cutout, but in this case, the welder cut out further than he was supposed to, according to the plans. They had it jacked off the picture. You can't see it at the end bent. So what happened? You know, they had to crib up down here to support that beam. You could have a failure. You need to make sure, first and foremost, that traffic's off when you're doing these area repairs like this. Make sure you don't have live traffic running over these beams. They should be pushed over to a different lane. You don't want them running over it as you're making these cuts. But in this case, you know, he cut out more than he was supposed to, and they had to do some extra shoring up down below it to support that beam. If they want to cut out that additional area, make sure you run it by structures management before you allow them to get out there and do that. Make sure that beam's not gonna fail. Have structures vetted out before you allow them to do that. All right, real quick on painting. Aaron Dacey's your guy. He's the materials and test unit. Look on that page on your telephone directory. He's the guy, he's the guru that you're going to call. If you don't call him, you can call me, and I'm going to turn around and call Aaron Dacey. All right. You can call Marcus or your area construction engineer if you're in a different division. He's going to turn around and call Aaron Dacey. And you can also call the resident, but he's going to end up calling Aaron Dacey too. They have their coding certifications. They're the gurus in paint. Aaron is active in the reserves, so sometimes if he's not available when you call down there, Richard Maxson is another contact. He's also expert on paint coatings. There's a lot that goes into those, but if you got any paint questions, if you have a painting contract or you happen to damage the paint when you're out doing one of these rehab contracts, touch base with these guys. They'll be the ones you want to talk to.